By the early 1940s, the United States faced a problem of unprecedented scale. Following the entry of the United States into the Second World War in December 1941, American military planners confronted the reality that modern industrial warfare required quantities of aircraft far beyond pre-war production levels. Heavy bombers in particular were central to American air strategy. They were expensive, complex, and slow to manufacture using traditional methods. One aircraft emerged as a central focus of this challenge: the consolidated B-24 Liberator. Designed in the late 1930s, the B-24 was a long-range, four-engine-heavy bomber with a high aspect ratio wing and significant payload capacity. By 1941, it had already been adopted by the United States Army Air Forces and several allied nations. However, demand quickly exceeded the production capacity of existing aircraft manufacturers. In response, the U.S. government turned to the civilian industrial sector. Among the companies approached was the Ford Motor Company, led by Henry Ford and his son Edsel Ford. Ford was known for its pioneering use of assembly line techniques in automobile manufacturing, not aircraft construction. Nonetheless, government officials believed that Ford's experience in mass production could be adapted to military aviation. The result was the Willow Run bomber plant, located near Ypsilanti, Michigan. Conceived in 1941 and operational by 1942, Willow Run was designed to produce B-24 bombers at a scale and speed never before attempted in aviation history. At its peak, the plant would claim the ability to complete one bomber every hour. This documentary examines the history of B-24 Liberator production at Willow Run between 1942 and 1945. It focuses on the industrial decisions that made such production possible, the workforce that carried it out, including large numbers of women workers, and the strategic impact of these aircraft on the Allied air campaign over Europe. The account that follows draws on Ford Motor Company production records, U.S. government archives, wartime reports, and documented worker testimonies. Interpretive statements are clearly identified as such. The objective is not to dramatize events, but to explain how industrial capacity, labor organization, and military necessity converged to reshape both warfare and manufacturing during the Second World War. The consolidated B-24 Liberator was conceived as a response to evolving military requirements in the late 1930s. The United States Army Air Corps issued a request in 1938 for a heavy 8 bomber with longer range and higher cruising speed than existing designs. Consolidated Aircraft Corporation responded with a prototype that incorporated several unconventional features, including a high-mounted, thin wing known as the Davis wing, which emphasized aerodynamic efficiency. The B-24 entered service in 1941, compared to the Boeing B-17 Flying Fortress. It offered greater range and a higher maximum payload, although it was often considered more difficult to fly and less robust under combat damage. Despite these differences, the U.S. Army Air Forces viewed the B-24 as essential for long-range bombing missions, maritime patrols, and transport roles. By early 1942, American war planners anticipated large-scale strategic bombing campaigns against Axis industrial centers, particularly in Nazi-occupied Europe. These plans required bomber formations numbering in the hundreds, operating repeatedly over long distances. Loss rates were expected to be high. Aircraft production would therefore need to exceed replacement needs, not merely match them. Existing manufacturers, such as Consolidated, Douglas and North American were already operating near capacity. The scale of production required exceeded what the traditional aircraft industry could deliver on its own. This led to a decision by the U.S. government to involve non-aviation firms with experience in high-volume manufacturing. Ford Motor Company was selected as a primary candidate. Although Henry Ford had previously expressed isolationist views, the company accepted the contract under government pressure and economic incentives. The task assigned to Ford was not simply to build aircraft, but to reimagine aircraft production using automotive methods. According to documented planning materials, Ford engineers sought to apply moving assembly lines, standardized parts, and simplified subassemblies to the B-24 design. This required extensive coordination with Consolidated Aircraft, which retained design authority. Early disagreements emerged over tolerances and methods. As aircraft manufacturing traditionally relied on skilled hand-fitting rather than interchangeable parts, historians generally agree that these tensions slowed initial production. However, they also note that the collaboration ultimately led to improvements in standardization that benefited the entire B-24 program. By mid-1942, the groundwork had been laid for an experiment in industrial scale that had no direct precedent in aviation. The Liberator, therefore, became more than a weapon. It became a test case for whether mass production principles could be applied to complex military aircraft under wartime conditions. The Willow Run plant was conceived as a purpose-built facility rather than an adaptation of existing infrastructure. In early 1941, the U.S. government approved funding for a massive aircraft factory to be operated by Ford Motor Company. The chosen site was farmland near Ypsilanti, Michigan, close to Detroit's industrial base and transportation networks. Construction began in April 1941. The facility ultimately covered approximately 3.5 million square feet under a single roof, making it one of the largest industrial buildings in the world at the time. The layout was designed to support continuous flow production, with raw materials entering one end and completed aircraft exiting the other. Documented engineering plans show that the plant included long, straight assembly lines, overhead conveyors, and dedicated subassembly areas for wings, fuselages, and engine installations. Rail spurs and road access were integrated into the site to facilitate material delivery. Despite its scale, Willow Run faced immediate challenges. Aircraft production required precision far beyond automobile manufacturing standards. Early in 1942, reports from the War Department noted quality control issues, including misaligned components and inconsistent tolerances. These problems resulted in delays in rework, limiting early output. The first Willow Run assembled B-24 did not leave the plant until September 1942. And even then, production numbers remained modest. Monthly output during the first half of 1943 was well below government expectations. Ford engineers and Army inspectors engaged in ongoing revisions to production processes, tooling, and worker training. Historian interpretations differ on the causes of these early difficulties. Some emphasize Ford's inexperience with aircraft production. Others point to the unprecedented complexity of attempting to mass-produce a heavy bomber using automotive techniques. There is general agreement, however, that Willow Run represented a steep learning curve rather than a failure of concept. By mid-1943, production rates began to increase steadily. Process changes included improved part standardization, closer coordination with suppliers, and revised inspection protocols. As these measures took effect, Willow Run moved closer to its intended role as a high-volume bomber factory. The plant itself became a symbol of American industrial mobilization. Its size, output goals, workforce reflected a shift from peacetime manufacturing to a wartime economy organized around sustained mass production. The operation of Willow Run required a workforce on a scale comparable to a small city. At its peak, the plant employed more than 40,000 workers. Many had no prior experience in aircraft manufacturing. Recruitment drew from southeastern Michigan and beyond, including rural migrants and urban workers displaced by wartime economic changes. A significant portion of the workforce consisted of women. As large numbers of men entered military service, industrial employers increasingly relied on female labor. This shift was encouraged by government campaigns that promoted women's participation in war production. One of the most well-documented examples from Willow Run is Will Monroe, a riveter employed at the plant. Monroe became publicly known after appearing in the U.S. government promotional films encouraging women to work in defense industries. Her role at Willow Run is confirmed through employment records and wartime publicity materials. Worker testimonies collected during and after the war describe extensive on-the-job training programs. New employees were taught specific tasks rather than full aircraft assembly, reflecting the division of labor necessary for mass production. Riveting, drilling, wiring, and inspection were among the most common assignments. According to contemporary reports, working conditions were demanding. The plant operated around the clock in multiple shifts. Noise levels were high and safety risks were present, particularly during early production phases. Government safety inspectors issued periodic recommendations, leading to incremental improvements. Documented diaries and interviews indicate that many workers expressed a sense of contribution to the war effort. Though motivations varied, some cited patriotism, others economic necessity, there is no evidence in official records of uniform emotional responses among workers, and historians caution against assuming a single shared experience. Labor relations at Willow Run were generally stable but not without tension. The United Auto Workers Union represented many employees, and disputes over wages, hours, and working conditions occurred intermittently. These were addressed through negotiations involving Ford management and federal mediators. The integration of women into industrial roles at Willow Run did not permanently alter gender employment patterns after the war. However, during the period from 1942 to 1945, their participation was essential to sustaining production levels. Plant S output depended on a workforce assembled under extraordinary circumstances, trained for highly specialized tasks. By late 1943 and into 1944, Willow Run reached the production levels originally envisioned by wartime planners. Ford production records and U.S. Army Air Forces reports document a steady increase in output, culminating in early 1944, when the plant achieved its highest production rates. At peak performance, Willow Run was completing approximately 1 B-24 Liberator per hour. This figure referred to aircraft leaving final assembly, not including those undergoing testing or modification. While exact hourly output varied, the claim is supported by multiple government and corporate records. Several factors contributed to this achievement. First, the standardization of parts across B-2 for variants reduced assembly complexity. Second, suppliers improved their reliability, ensuring a consistent flow of components. Third, worker experience increased, reducing errors and rework. The assembly line itself was divided into clearly defined stages. Fuselage sections moved progressively through drilling, riveting, wiring, and installation phases. Wings and tail assemblies were produced in parallel and joined late in the process. Engines and armaments were installed near final assembly, followed by inspection and testing. Army Air Forces inspectors remained on site throughout production. Their role was to verify compliance with military specifications rather than manage daily operations. Reports indicate that acceptance rates improved significantly by mid-1944, reflecting higher build quality. Historians generally interpret Willow Run's production success as evidence that mass production principles could be adapted to aircraft manufacturing under certain conditions. However, they also note that this success depended on extraordinary government support, including guaranteed contracts, priority access to materials, and regulatory flexibility. Between 1942 and 1945, Willow Run produced more than 8,600 B-24 Liberators. This accounted for a substantial proportion of total B-24 production across all manufacturers. The plant's output contributed directly to the expansion of Allied air power during the later stages of the war. The ability to sustain such production levels over time distinguished Willow Run from earlier industrial experiments. It demonstrated that volume, consistency, and speed could coexist in the manufacture of complex military equipment, provided sufficient organizational resources were available. B-24 Liberators produced at Willow Run were delivered primarily to the United States Army Air Forces, though some were allocated to Allied forces under Lend-Lease agreements. Once deployed, these aircraft served in multiple roles, including strategic bombing, anti-submarine patrols, and transport. In the European theater of operations, B-24s were assigned to several air forces, including the 8th and 15th Air Forces. They participated in long-range bombing missions, targeting industrial facilities, transportation networks, and military infrastructure in German-controlled territory. Mission records indicate that B-24s often flew in large formations, sometimes numbering several hundred aircraft. These formations were designed to concentrate defensive firepower and increase bombing accuracy through coordinated drops. The availability of large numbers of bombers made such tactics feasible. The impact of strategic bombing remains a subject of historical debate. Documented facts show that bombing disrupted production, damaged infrastructure, and forced the diversion of German resources to air defense. However, historians differ in their assessment of its overall effectiveness in shortening the war. Willow Run's contribution was primarily quantitative, rather than qualitative. The plant did not produce a unique variant of the B-24, nor did it alter combat doctrine. Instead, it ensured a steady supply of aircraft that allowed air planners to replace losses and expand operations. Operational reports from 1944 indicate that bomber availability improved significantly compared to earlier periods. While losses remained substantial, production outpaced attrition by late 1944, enabling sustained pressure on Axis targets. It is important to note that individual aircraft histories varied. Some Willow Run-built B-24s completed numerous missions, while others were lost shortly after deployment due to combat or accidents. Records do not support uniform performance outcomes. The strategic value of Willow Run production lay in its contribution to industrial capacity rather than tactical innovation. By ensuring that aircraft numbers met operational demands, the plant supported the broader Allied air campaign during a critical phase of the war. As the war in Europe approached its conclusion in early 1945, demand for new bombers began to decline. Military planners anticipated reduced requirements following Germany's surrender, and production contracts were reassessed accordingly. Willow Run continued B-24 production into mid-1945, but output slowed as contracts were canceled or reduced. Following Japan's surrender in August 1945, remaining military production ceased. Ford Motor Company terminated aircraft manufacturing at Willow Run shortly thereafter. The workforce was rapidly downsized, and many employees returned to civilian industries or left the labor force entirely. Government contracts that had sustained the plant were concluded. The facility did not immediately find a new purpose. In the post-war period, Willow Run was repurposed for various industrial uses, including automobile production under different ownership. Portions of the original bomber plant were eventually demolished or modified. From a historical perspective, Willow Run represents a temporary but significant transformation of American industry. It was created for a specific wartime need and dismantled or repurposed once that need ended. Historians generally interpret this pattern as characteristic of total war economies, where production systems are rapidly assembled and disassembled in response to military requirements. Willow Run's legacy lies not in its longevity, but in its demonstration of what industrial mobilization could achieve under centralized coordination. The production of B-24 Liberator bombers at Willow Run between 1942 and 1945 illustrates the central role of industrial capacity in modern warfare. Faced with unprecedented demands, the United States government turned to civilian industry to expand military production beyond traditional limits. Willow Run was neither an instant success nor a flawless operation. Early production difficulties, labor challenges, and quality control issues are well documented. However, the plant ultimately achieved production levels that reshaped expectations for aircraft manufacturing. The workforce, including thousands of women workers such as Will Monroe, played a critical role in this achievement. Their participation was shaped by wartime necessity rather than long-term social change, but it was nonetheless essential to sustaining output. From an operational standpoint, Willow Run's contribution was measured in numbers. By delivering thousands of heavy bombers, the plant supported sustained air operations over Europe during a decisive phase of the war. Historian interpretations vary regarding the broader impact of strategic bombing and industrial mobilization. What is not disputed is that without facilities like Willow Run, the scale of Allied air power achieved by 1944 would not have been possible. The story of Willow Run is therefore not solely about aircraft or factories. It is about how industrial organization, labor, and government policy converged under wartime pressure. Its significance lies in demonstrating how production capacity became a strategic factor alongside tactics and technology. When the war ended, Willow Run faded from prominence. Yet its brief existence left a lasting imprint on industrial history, illustrating both the possibilities and the limits of mass production in the context of total war.